Welcome back to the Humanoid Systems Analyst. Now, on Sunday, we looked at the humanoid war, the battle between Tesla, Boston Dynamics, and Figure for market dominance. But today, we're going deeper. We're putting the hype aside to look at the three specific technologies that moved us from laboratory experiments to industrial workers in the last 12 months. We are talking about the actuators that provide the muscle, the tactile sensors that provide the nervous system, and the end-to-end neural networks that serve as the brain. Now, if you've ever wondered why a robot can suddenly fold a shirt without a single line of if-then code, or how a 125-pound machine can catch a falling object with millisecond precision, this is the breakdown for you. I'm Marcus J, and this is the Monday Deep Dive. Now, let's start with the muscle in 2026. The core hardware challenge is power density. How do you pack enough torque in a shoulder or a knee to move like a human without making the robot look like a forklift? That's the question. The industry has split into two main schools of thought: integrated rotary actuators and planetary roller screws. First, let's look at that rotary actuator. This is what you'll find shoulders and hips for Tesla Optimus Gen-3. These are all in one modules. Inside the circular joint, you have a frameless torque motor, a high precision encoder, and a harmonic reducer. The harmonic reducer is a secret sauce here. It allows for massive gear ratios, often 100 to 1, in a tiny space with zero backlash. Now, in 2026, we've seen a shift toward peak carbon fiber hybrid gears, which are 30% lighter than the steel gears we used in 2024. This is why Optimus looks so lean. The muscle is literally built into the bone. But then you have the linear actuators, specifically the planetary roller screw. You'll see these in the forearms and calves of robots designed for high payload work, like the Boston Dynamics Atlas. Unlike a standard ball screw, a planetary roller screw uses multiple threaded rollers to distribute the load. This gives the robot industrial grade stiffness. When Atlas lifts a 50-kilogram crate, it isn't the motor doing all the work, it's the mechanical advantage of the roller screw. It's the difference between a high speed electric car and a heavy duty diesel truck. One is built for agility, the other is built for torque. Now let's talk about the nervous system, tactile sensing, and uSkin. Hardware is useless if the robot is numb. Now, for years, robots rely almost entirely on computer vision. They could see a cup, but they couldn't feel how slippery it was. In 2026, the tactile revolution has changed everything. The breakthrough is a technology called uSkin, or 3D tactile arrays. If you look at the fingertips of the Figure O3 or the Tesla hands, they aren't just rubber pads. They are embedded with a grid of magnetic taxels. When a robot touches an object, these taxels measure displacement in three dimensions: X, Y, and Z. This allows for something called incipient slip detection. Think about when you pick up a heavy glass of water, your brain doesn't wait for the glass to drop before you tighten your grip. Your fingers feel the microscopic vibrations of the glass starting to slip. Now, in 2026, humanoid hands are now sampling these tactile signals at 1000 hertz. This is why we're seeing videos of robots handling eggs, salt fruit, and even threading needles. That's crazy, isn't it? They aren't just following the path, they are reacting to the friction and surface tension of the object in real time. Without these sensors, general purpose robotics is impossible. Visions tell the robot where the object is, but touch tells the robot what it is doing. Now let's move on to the brain, end to end versus the VLA models. Okay. Finally, we have talked about the brain. We are currently witnessing the death of tradition programming. We no longer write code to tell a robot move arm XYZ coordinates. Instead, we use end-to-end neural networks. Think of it. Think of it as pixels to torque. In Tesla Optimus, the camera feeds raw pixels directly into a signal, massive transformer model. The model has been trained on millions of hours of human video and teleoperated data. The model doesn't calculate a path, it predicts the necessary motor torque to achieve a goal. It's the same way GPT predicts the next word in a sentence. But Figure AI has taken this a step further with their Helix VLA model, also known as the Vision Language Action. This is a system, uh, one half system two architecture, also known as system one, system two architecture. Now, system two is a thinker. It's an internet pre-trained model that understands concepts. If you tell a figure 003 or 3, depending on how you want to say it, to find something to clean this mess, System 2 understands that a towel or a sponge is that correct tool. Now, System 1 is the reactor. It takes a high level goal and handles the 200 hertz motor adjustments needed to actually wipe the table. This allows for zero shot generation. A robot can walk into a kitchen it has never seen, identify a tool it has never programmed for, and perform a task purely through common sense logic. Man, that's crazy, isn't it? It's got me thinking about not only AI but quantum computing as well. Okay, so now this is the GPT moment for physical labor. We have moved from if then to imagine act. Now let's move on to hardware software inflation. As we look at the state of the industry in 2026, the conclusion is clear. The hardware and software have finally met in the middle. We have the actuators for the power, the tactile sensors for the feedback, and the neural nets for logic. The bottleneck is no longer can a robot do this? The bottleneck is can we build them fast enough? That's the question. This is why we saw the LG pivot we discussed a few days ago. The demand for high density humanoid batteries is outstripping the supply of EV cells. Now, Tesla is betting on the generalist brain and automotive scale manufacturing. Boston Dynamics is betting on industrial muscle and precision control. And Figure is betting on semantic logic through its OpenAI partnership. Now, I'm Marcus J, and this has been a deep dive into the components of the 2026 economy. If you want to see the supply chain breakdown of how these parts are actually sourced from places like Sunha and Green Harmonic, make sure you subscribe for the next video. Now, leave a comment below which of these three would you say is a bottleneck? Is it the brain? Is it the muscle? Is it the nerves? I'll be in the comments. I'll see you in the next one.